Let's continue with question number 3 of race number 0 of the Secureum Bootcamp. So we again have a little snippet here, and it says the given contract snippet has a missing use of only admin modifier on transfer funds. So we have an only admin modifier, and we are to assume that this is correctly implemented. So an only admin modifier usually does what it says. If added to a function, it basically makes sure that only the administrator of the contract is able to call this function and to use the function to make some sort of state changes on the contract probably. So there's no code here, it just executes the body of the function that it is added to, but nothing else. But we are to assume that there's more. We also see that there is the transfer funds function, and we also can see here that it is public and it does not have any modifier. We are furthermore to assume that other required functionality is correctly implemented. So we assume that this is some kind of DeFi protocol, and probably this transfer funds function, which apparently sends the specified amount of ether to this specified recipient, both passed in as function parameters, and it basically allows anyone, because it's public and has no modifiers and no checks, it allows anyone to send arbitrary amounts to arbitrary addresses. That sounds problematic. So most likely, no matter what sort of DeFi project this is, most likely this is not intended. Most likely it was intended for there to be an only admin modifier here. So arguably yes, the use of the only admin modifier is missing on transfer funds, because otherwise anyone would just be able to take all of the funds inside of this contract, at least all of the ether. B, the given contract snippet has missing return value check on transfer. You can see here that transfer is used to send the amount to the recipient. And the thing with transfer, like transfer is one of the ways on how to send ether from one address to another basically. And transfer does not return any return values. Transfer instead, it attempts to send the amount to that address, and if it succeeds, the function just continues on normally, and if it fails, instead it will revert here. Reverting means everything that has happened so far is being reverted, pulled back, like it never happened, and we get an error message which is then bubbled up through the function calls basically. And transfer therefore has no return value because it would revert, and therefore this is not missing, therefore B is incorrect. But it would be interesting here to think about, like, where is this question coming from? Because there is actually another way to transfer funds which does have a return value, as this says, and that is when we use the send function. If we do recipient.send and send the amount, it would indeed complain here because we're not checking the return value, and there we would have to set a bool send, and then we would have to check that bool, and for it to have the same effect like using transfer, we can just do a require basically and just do it like this. So now we are sending the amounts with the send function, and we will get a bool, and we will make a require, and if the send bool is true, then it again continues on normally, but if it is false, this require will revert just like it would revert with this transfer function. Now the important thing to know here is that actually using transfer or send is discouraged, because they only send a limited amount of gas. I think it was 2,300 gas to the contract receiving. So if it is a contract, it could be an EOA, it could be a normal address with a private key. In that case, we could use transfer. There's nothing against using transfer if we are 100% certain that the receiving account will be an EOA account. But we should stop doing this assumption, because in the future the hope is that we will have all contract accounts, basically, especially with account abstraction. It is likely that in the future there will be less and less EOA accounts and more contract-based accounts. So we should not make the assumption that addresses are supposed to be EOAs. And the problem here is that when we send Ether to a contract, these contracts will have, for example, a fallback function defined, or it will have a receive function defined. And if either of these are defined, basically, the contract will be able to receive funds. And the thing is that within these functions, which are executed when the contract receives funds, things can happen. Oops. Stuff. There could be stuff here which consumes gas, and there is the chance that it consumes more gas than transfer and sends to this fallback function. And then trying to send the funds to these addresses would always fail, and that might result in some kind of denial of service attack. Maybe it forever bricks the contract because it goes through a loop trying to send the funds out or stuff like that. And that's quite problematic, so therefore we should avoid using transfer and send, and instead we would have to use the low-level function, which is call. So we would do a recipient.call, and we don't have to send anything with the call. So this would be the call data that we're sending, but we don't actually want to send any call data here, so we can just send an empty call data string. And then here we would be able to specify a value that we want to send, and this value would then be the amount. Don't forget the semicolon. And then again, here we have return values, but we have more than just one return value. We have a bool, success bool, and we also have bytes data. But we don't actually want the data here because we're not going to use it. So we're just gonna put a comma here, and we're gonna do a require the success to be true. And now we basically, it looks very similar to send, but the difference here is that most of the gas is forwarded. There's the special rule where the gas forwarded on calls like 1/64, I think, is held back for the caller himself in case that they need, in case the callee consumes all of the gas that they received, then the caller still has the 1/64 of the gas left to finish up what it needs to finish up, and hopefully that is enough. But otherwise, all of the other gas is being sent to the callee. To mimic the behavior that a transfer and send has, we can basically also here not only set a value, but also set a gas amount. So we could set like 2,300 gas, which would mimic the behavior of the above functions, but we don't want that because that would be problematic. And now another way to send the Ether funds to a recipient would be self-destruct. We already had this in the previous question, self-destruct, and then we could send it to the recipient. Obviously the difference here is that we can't specify an amount. Instead, all of the Ether that this contract holds is being sent to the recipient. But here again, there is an important difference between self-destruct and all these other functions, because self-destruct does not execute neither fallback nor receive. When you send funds to another contract via self-destruct, this contract will not be called. You cannot hook into receiving Ether as you can with receiving Ether from call, send, or transfer. it will basically, the code in the Ethereum node, it will just take the current balance of the recipient, add whatever the balance of the contract being destructed has, and then store this updated balance. Nothing else happens basically. And obviously the balance of the sender will be reset to 0. So this is an important difference. All these execute fallback and receive functions, but self-destruct does not. Okay, and that's about sending. So do we have a missing return value check on transfer? No, because transfer does not return anything. Do we have unprotected withdrawal of funds? Yes, because we can literally withdraw all of the funds of the test contract. So we do have an unprotected withdrawal of funds because anyone can do this. None of the above can again not be, and ANC is correct. That's it.